The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. My name is Mark Ishan. Welcome to the webinar coming to you from North Adelaide at the moment. We're having a rather condensed version today. We were hoping to take about an hour to go through it, up to an hour, so please hang in there. We will be going through, just to let you know, we are real people here. I'll share the webcam a little bit later on, but you should only be hearing sound and seeing the screen, and you should have in front of you at the moment. You should now be seeing our first slide in the presentation. So alongside me is Steve Sindler from 2XE, who will be presenting the part of it. This program has been developed with in partnership with Zero Waste SA. Oz Industry have been a major part of our rollout of the toolkit sessions in this first phase. And of course, the Department of Resources, Energy and Tourism have funded the program. Let me move into it. What we want to do today is just go through the context of it. So I'm going to cover that. Then I'm going to hand basically over to Steve, who's going to go through the toolkit itself with brief mention of the CTFFIP, which is the Clean Technology Food and Foundries Investment Program. Although I'll just cover on that briefly. Steve may not have a lot of time, and so on. Now we hope we'll finish around about 11 a.m. That is Adelaide time, and at the end of it, what we would like you to do is complete the feedback survey. That will give you the option to register for further assistance, which I'll just explain a little bit more about other things that are going on in the program. Sorry about that. Now, of course, I have to acknowledge that the Department of Resources, Energy and Tourism funded this program as part of the Energy Efficiency Information Grants Program and so on. That's been very important there. I would also like to stress that Zero Waste have been instrumental in developing this program and remain our partners and are in fact a major player in this. So thanks to Zero Waste. And we have Aubrey Thomas from Zero Waste as a panelist. So if anyone has any questions, you can raise your hand or post the questions in the questions panel of your control panel from the GoToWebinar. Okay. Now, energy efficiency is only a part of broader effectiveness that we are concerned about in wineries. What we're going to do is just talk a little bit about that. Steve will go into that, but that we don't have a lot of time, so we'll go straight into looking at the Winery Energy Saver Toolkit itself. It is an interactive PDF. There are some checklists and about the data that you need to prepare for suppliers and also for the opportunities that you're trying to look for. There are also case studies that will be loaded. At the moment, only some of those documents are finalised, but they will all be available free from the South Australian Wine Industry Association's website. I'll just talk a bit about Oz Industry Clean Technology Food and Foundries Investment Program now. The Oz Industry is part of the Clean Energy Future Package, as you all know, and funding is available for energy efficiency opportunities. It can be either one-to-one for smaller, medium-sized enterprises, and there have been a number of wineries that have achieved that. Larger wineries, it's I think 1 to 3. 1 to 2. That program is very closely aligned to what we're trying to do here. So that's why Oz Industry have also joined us in the face-to-face seminars that we've been conducting around South Australia. Now, when I talk in the survey, there are three things that you can register interest for further assistance if you're a winery. The first is within the West program, the Winery Energy Energy Saver Toolkit, that is the program ourselves, we are able to come out one-on-one to you on site and provide some assistance. Of course, there are some limitations, and we do know we've got some interstate people registered today. You need to be in South Australia, and you also need to be Sawyer members. You don't have to be in South Australia to be a Sawyer member, but I think given the budget, we probably, if you were a Sawyer member from interstate, we could probably possibly come to some arrangement. But you do need to be that. For the Zero Waste Industry Program, you can get some assistance as well, and that can be broader. It can also be anything to do with resources, energy, energy, wastewater, any of those kinds of areas. In the questionnaire, you'll see some more information about that, or the survey, so you can put on that. Oz Industry, now when we do the workshops, they actually come with us, and you can talk to them one-to-one about getting an application ready. In today's circumstance, that's not possible. However, we can put you in contact with them, so you can please contact us, and Steve will give you all the contact details for us all later on. Okay, now let me just check. Whoops, excuse me. Just having a bit of a. There we go. So at the end of this hour, what I'd like is the session feedback survey with expression of interest to you. Back to us, so fill in that survey, please. And you can access the toolkit at that web address there, which is winesa.asn.au. And you'll find all the information there. What you can do is start, download the Key Opportunities Register templates and start listing the things that you want to do next, and we can move with that. Okay, that basically is where I will change over or hand over to Steve now, who's going to take you through the rest of the program. So I'm just going to change my presenter over to Steve and welcome him to the webinar. So here we go, Steve. I'll hand over to you.
All going. Hi everyone. Thank you very much for coming along today, and thank you very much to Mark for the introduction. Just a very quick 2-second background on ourselves at 2XC. Both me and my colleague Nick have been working on resource efficiency and productivity in the wine industry and other industries for quite some time now, dealing closely with Mark at Sawyer as well as Aubrey at Zero Waste and with the Oz Industry guys as well. Sorry.
I had Steve on mute there, so we'll just start that again.
Oh, we'll start again. I was already going. Sorry about that, everyone. Hello again. Just wanted to say thank you very much for coming along today, and also just to Mark as well, and to Aubrey for their partnership through this program for West. So we've been heavily involved with the West development, and a little quick bit of background on us. Both me and my colleague Nick have been working in the wine industry for time, both on resource efficiency and productivity improvements. We won't take up too much of your time because we do have a lot of ground to cover in the next 50 minutes or so. But this session really is about introducing you to the West Toolkit and opening up the opportunity for some of the one-on-ones for those that are able to access them. We found this has been gated by the industry guys to access that support. You are running businesses, you're very busy running those businesses, and energy efficiency may not be, the core priority for you, and rightly so. You've got focus on making and selling quality wine. So do have a lot to go through, and I'll skim through quickly, but we should be able to, I think Mark will be keeping track of any questions that come up along the way, and we'll try and answer those as we go, as well as any concerns that you might have. I guess the focus of today, developing the toolkit, has been an important step for this program to give wine industry members some ideas, or some that you may have already gone through, and maybe worth pursuing to help cost cut and improve productivity. Energy efficiency is one of those ways, but it's definitely not the only way. And there's not, what we're trying to present here is not an energy efficiency guide. It is a starting point. So this is something that we intend to be updating in future, and something that we intend to use and to test through these workshops and presentations with the members and other to really ground truth ideas. Lots of you may have ideas that you've seen come here. We'd love to hear about those, as well as some ideas that we've covered that look good in theory, but practice don't necessarily really stack up. So part of this is about testing it and getting your feedback, so that we can continue to update the toolkit and improve, along with other possible support such as the case studies and such that I mentioned, and that we have a useful and updatable resource for soil stewardship. Okay, so not really sure about the extent to which most people have been involved with energy efficiency work before, definitely within their own businesses, and some I know that we've got a range of people potentially online today as well. So, but I guess we're really not here to push the energy efficiency agenda as the solution to all your problems. It definitely, shouldn't have been the thing that you woke up and thought this is the thing to do yesterday. It does have to be taken in context of what your broader business priorities are. So what we're here to do is, ground truth this and ask, how do we approach energy efficiency in a realistic way? We aim to put a little bit of context on the topic before jumping straight into the toolkit, but I'm going to get to that very, very quickly. So I guess what we're trying to show here, Mitch, is that we're not trying to do energy efficiency for energy efficiency's sake. It really is important an understanding of how it may affect your business, positive or negative way, and just acknowledging that energy efficiency isn't business. You want to be selling as much wine at the best quality and the best price, low input costs, and energy efficiency in the world is one way to approach that. So being mindful of the as said, sales and productivity should be business. Energy efficiency really is one of those things to help you reduce costs and control productivity on site. There is a lot to be done. We do a where is just user wineries. It's mostly about the actual winemaking process, but not so much about the bottling. Yet, but it's something that we can. It's all interested. So, also mindful that focus on energy efficiency. It does take a lot of time, and appreciating with this here are from very small to very large. Especially at the smaller end, people can be more thin on resources, both in terms of stuff to able to take on upgrades. And there is all of the competing pressures there at the moment. Work, finding and challenging, even just to take care of that. So part of this program is helping find the right opportunities in really being to engage with suppliers to do. One stress was that what works for one not work for another. Sort of just covers ground missions. There are a lot of processes out to larger wineries have capital to invest in larger upgrades versus those that might be more applicable to smaller ones. Where we do start small level. On that note, the mantra is that it really is mindset that people into effectively with energy efficiency saving. Small saving is to be made, and when you collectively up all the small steps that you can make, they do add up to quite a lot in the long run as well. But supporting your staff really on board as practices. So just looking quickly at the areas that we focused on in the West toolkit. So by the main technologies, the refrigeration storage being the big hitter for wine businesses, storage, fermentation, cold stabilization, etc. It really is the biggest area of impact. Although it is also, it is also a hard one to deal with because, there's about we're expecting people to be experts in, refrigeration. The other area is pumping, also, and compressed air, not insignificant in their contribution to efficiency. As with hot water and steam, but more so when you think about gas supplies as well, so natural gas. And finally, with HVAC and lighting. I do apologise just quickly because we are going through the webinar if screens aren't coming up, in time, so I may be speaking slightly ahead of the points that come up here, but I'll try and keep an eye on screen and make sure that you actually do see it come up. Okay, so West Toolkit. How to get the most out of the West Toolkit. I'm just quickly, in a couple of minutes, bring up the toolkit itself so you can see a version of it. That's not hasn't been released yet because we are still waiting for finalisation review comments back on the tool. But as soon as it is available, we'll be able to on the tool so that you have it. Okay, so I guess the main thing is to give people ideas about energy efficiency across, the breadth of the operations, and really to be able to spend some time dealing with your suppliers on working out, what can be effective in your situation. On that, it's not intended to turn individuals into efficiency experts. That's, you've got, well, in many cases, a lot of experts on as well, and what we want to do here is give you enough information to be able to be informed about out there and have a conversation with either your staff or either with your equipment size, others such as to go over what the opportunities are. Just as well, the toolkit is based on equipment upgrade and process equipment upgrade in terms of the plant itself. It's not specifically targeted towards staff engagement practices at the moment, which is something that we may look at more in the future. But again, this is more about being able to get capital investments and decisions on the best worthwhile to proceed with. So that's just covering that ground there, and I guess just to put a little bit of a disclaimer as well at the current point, it's not a silver bullet, not going to all your energy efficiency and other productivity problems on site. There's a lot of further work that we can do to build this up, and there's also there's a lot of, it does take some work internally as well to get the right information and to work with suppliers to scope out opportunities. So the West Toolkit, I'm just going to camp out of my presentation for a second and just jump over to the toolkit itself. So hopefully you can see come up and excellent. How do I use this version? Oh, there we go. There we go. Okay, sorry guys. Right. So the West Toolkit, it's like Mark said, an interactive PDF. It is designed to act like a web tool. You might say, why not just have it online? Yep. So the itself, great. So we're just having a little bit of issues coming up on the screens properly, so you can all. Yes, it is an interactive PDF, and rather than just have it stationary on the web, we wanted to make sure that this was a tool that people could necessarily download and use when necessarily connected online. Can take around with an iPad and talk to staff about and look at different opportunities on the move as well. So Just to give you a quick down across the top of the tool there, you see 6 different technology areas, as well as the last section around the case for how to, just some ideas and some guidance on how to assess these opportunities, and make sure you're managing the process through from concept through to the end of your payback as well. So we've got the refrigeration storage. You might be able to see my cursor go across the screen there, from the areas from pumping, compressed air, HVAC, lighting, over to the business case as well. And the tool's really divided into 3 areas. First of all, we've got a first step around basically some of the lower hanging fruit, being able to options to upgrade or to work with within your existing equipment to optimize what you've got in place. There is some minor upgrades to do with that, or dealing with maintenance mechanics and such to set controls. Moving on to step 2, which is really focused on the larger capital projects as well, to upgrade equipment, replace equipment, really hit higher hanging fruit, but potentially resulting in significant energy savings. Finally, step 3 is more around the process, helping you to collect some data so that you can have a realistic conversation with internally and with your suppliers about what the opportunities may be and what the savings are and what the potential is to make these updates. So if I just click on say refrigeration at the moment, you'll see that it's just a cover page. You can click on any one of those different steps to jump straight to them, or if you're so inclined and really keen, you can scroll straight down the bottom right hand corner here from next page, all to look at all the different opportunities. And so to do that, I know Nick would probably highlight that I'd be getting stuck right into the numbers, but for those that want to jump straight to things, feel free to look across the top. I won't dwell on the actual toolkit any further, so we'll jump straight into the rest of the presentation. Get back to that. Okay, so I'll just wait for that to come back up. Great. Okay, so moving straight on to it. What we're going to do is step through each of the technology areas and really just highlight some of the key opportunities that we've found through the that we found and want to share through the tool at this time. Just give this very quickly. You only have about half an hour or so. So I need to ask questions or to have a look over these in details. You have the access to the opportunity registers on the portal, as well as one that does want that is able to take the one-on-one support. That's really what we're here for, to help you expand on and scope out opportunities as well. So in refrigeration tanks, in step 1, which is really exploring options to optimize equipment, we've staged it out. The first one here, using the maximum temperature settings, so that you're not making equipment harder than you need to. If you're trying to lower, which is obviously refrigeration, it's relatively straightforward to thinking behind behind a lot of these points. And as you see, there's a lot of repetition between the technology areas, because essentially a lot of this equipment is based on the same the same 4 parts. They're all based on drives and motors, pumps, which feature the same efficiency factors as well. So maximum temperature settings is probably the first step to see where you can actually, if you're operating things at -4 degrees at the moment, it doesn't need to be at that temperature. Could you have it at +2 instead? So I'll highlight with Mark if there's anything I need to pick up, but I'll just keep going through otherwise. Probably one of the biggest opportunities for businesses at the moment, and it's something that we're seeing a lot of here in with main load and your peak times. So really where this comes into play is when you're having a lot of equipment on, and it's specifically coming on all at the same time, where you're going to get a high demand spike, and I'm not sure how much people necessarily know about tariff structures, but most mid to definitely the larger size businesses will have both the consumption cost as well as demand cost as well. And that demand cost is based on your peak usage. Instantaneous peak usage across a certain window, generally here it's between the hours of 12 and 8 PM on a half-hourly basis. So if you hit your peak during any of that time, that is what your maximum peak that you hit during that time, where your recorded stays that way throughout the year, regardless of what you do under that you're paying. Peak, whatever you exceed it by will be a new peak, and that's obviously caught out, I guess, by what we're here is working out how they can manage their load better, so you're acting out your consumption at any time and bring out that load a bit as possible to flat. So here, any load in that might some of your tanks, refrigeration options now. So one way to reduce your option is to be variable flow filler. So whether it's a whether it's a refrigeration as well as but if you get variable chill, that would be varying load of refrigerant through the system, reduce the power by adjusting what it's supplying, the load that you're actually putting on it at any one time, as well as the temperature conditions, because obviously it's going to be hotter during the day, it's cooler during the night. Nighttime air for ventilation. So if it's cooler at night, you may have the opportunity to use air to provide some cooling to your plant rather than actively cooling it. And multiple smaller refrigeration in parallel. So rather than having one large of the top operating suboptimally, you might do think about side things to come on needed to meet specific rules. Next, seals and manageables, keeping all infiltration points quite tight is an important one. This is a couple of times we'll be talking insulation to a fair degree. One point where there are small difference in the how hard refrigeration plant has to work. So anything you can do to seal gaps to ensure that the space that you're cooling or the one that you're cooling, the refrigerator that you're cooling, we're talking about valving as well, not lose any heat or losing as much as using wastage. So another way to reduce peak demand is by using evaporative cooling or ice as a potential way. A good area for this is in pre-cooling of grapes must as well when coming night. So some people may be using bringing the grapes during the night because that time rather than bringing it in during the day to have grapes coming in cooler. Other options here which are fairly low to use off-peak electricity to provide additional cooling to grapes must is through evaporative cooling and storage. So that allows to spread the load rather than your refrigeration peaking out at one particular time or another. You can focus the energy on building up an ice bank and then using that ice bank over a period of time. Big one, and probably one of the very first ones that would really recommend people into if you haven't got this on the radar as a high priority in terms of energy efficiency at the moment, is ventilation. So it really is one of the biggest opportunities for the amount that you can save. You know, and it also helps you to size your equipment appropriately afterwards. We'll just go through the list here very quickly, but you know, that includes insulation on, you know, tanks, as well as insulation on cold stores, walls, and finally, go through that, but you know, tanks, cold store, walls, pipelines, the whole refrigeration circuit. Talking about refrigeration circuits, the pressure drop is another point that tends to make refrigeration units work a lot harder than they necessarily need to. And you know, this happens virtually everywhere. You know, you're running a winery over time, you install new pipe work, you install new tanks. There hasn't necessarily been a deal of work into making that pipe system as efficient as possible. So you might end up with small width pipes, you know, older systems, long runs that span over, you know 50, 100, 200 meters more as well. And you know, this is a kind of step that you would take. You know, you have to take these kind of steps quite seriously because they are potentially a large capital investment. So it's not something you would just do on the fly. This is something you would do when you have a major overhaul. But what we are really looking for here is, you know, in terms of minimizing pressure drop, you want to maximize the free flow of, you know, either refrigerant or wine or whatever you have going through the system. So you set this up across the board when we're talking about pumping as well down the track. But you want to maximize the free flow of liquid through the pipes, which means fatter, shorter, smoother pipe work are all points that are going to help you to minimize the pressure drop. Another thing that can probably be done to improve efficiency refrigeration system is to try and deliver the primary refrigerant to the end user. So a lot of systems, you know, will have both a primary and secondary refrigeration loop. By being able to directly cool through the primary refrigerant, you enable, you know, you're not having to go through a secondary heat exchanger. The primary refrigerant is often more efficient itself as a cooling and as a heat removal medium than the secondary refrigerant, you know, for example, ammonia over glycol and brine. So, you know, they do tend to be more effective, but you would normally only do it where you've got short runs and also where you're doing continuous cooling. Another option where you are using secondary refrigeration systems would be to install a second brine tank. The tank allows you to basically collect any of the warm brine that's coming back through the refrigeration cycle and you know, pre-cool that before mixing it with the, you know, the cold brine that's already been chilled down. So that's an opportunity that might come up in some places. Move through fairly quick, and refrigeration really is the biggest one that we're going to focus on. And what you'll see is a lot of repetition through the future ones. So we're not going to need to sort of strip through so in depth even now. So relocating a refrigeration unit. This is, you know, it's not an easy thing to do again, you know, but whether it's relocating the refrigeration unit or putting things around the refrigeration unit to help it run effectively is you know, can be quite a good. What you'll see is, you know, if the chiller is located outside a direct site or is located next to other hot equipment, it is running less efficiently than it needs to be, or than it could be. So what we're looking to do here is try and decrease the temperature of the, you know, compressor unit so that they can run in a more optimal condition, nicely ventilated, you know, away from hot and heat sources. Something you might actually find on your compressor systems with screw compressors is whether you have a direct injection oil cooling or, you know, refrigerant cooling versus having external oil coolers. External oil coolers are generally more helpful to improve efficiency. by using by keeping the heat away again, and by removing the heat through a shell and tube heat exchanger. Also, electronic expansion valves. What you may find is with some of the more traditional thermostatic valves that they do react a little bit more slowly or ineffective with controlling the expansion side of the refrigeration process. So getting an electronic expansion valve can often negate a lot of these, these inefficiencies caused with the thermostatic systems. Okay, so moving on to some of the things with condenser components particularly. So we're talking cooling towers and such here. In essence, centrifugal fans are a less efficient profile than axial fans. So any opportunity to move to an axial fan system is one that will likely help assist with reducing fan power consumption. Something to just bring up with your refrigeration mechanic. What have we got installed? Can we swap them over? Is it suitable? Likewise with an automatic purger, so contaminants do build up in the refrigeration system. So an automatic purger will just help keep those contaminants at a minimum level, and do so without intervention. Now you've probably heard a fair bit. Variable speed drives do come up quite often. They are very for minimizing energy consumption and basically matching the input from the compressor with the load that's actually being demanded by the refrigeration at any one point in time. What they're not good at is when there is a constant load. So if there is a constant load, or you're running at high load most of the time, then VSDs actually do introduce into the system. So it's something to be very careful of, because we have dealt with suppliers in the past that may just say, VSD, go for it, without actually taking into account what sort of conditions you're running. It really is important to go over this information with your suppliers and be confident in how your system is actually running and how it's going to make use of the plant as well. Similarly, where your system is running a constant speed but not necessarily full speed, there is an option to install multi-speed motors. So these are geared motors that run well at 1, 2, 3 different speeds, and could suit conditions where VSD might not be the way to go, which is a lot more. VSDs tend to be a widely varying type of mode, rather than 2 or 3 different speeds that would run. This sort of thing might come up. So between, as a good example, between looking at vintage when you're working at some plant at 80% load versus vintage when it might be running at 40% load, but it's still running constant. This next slide here, really just to finish up with getting towards the end of refrigeration, upgrading equipment, is just about installing better smarts around staging compressors. You may have 1, 2, 3 compressors operating parallel, and just providing that capacity control so that you're automatically switching and unloading compressors when they're needed. It's just it's relatively straightforward concept that you use what you need to when you need to. A couple of extra ones, and I guess these do be more directed towards larger wineries, but other technology types that aren't specifically to do with refrigeration but help to minimise refrigeration load or need. One such one is installing a centrifuge. So this is really aimed at helping speed up the clarification process, along with cross-flow filtration as well. So both of these technologies help speed up your back end of the winemaking process, and minimise the need for storage time or cold stab time as well. Just quickly to run through, this is a sort of cover-all point for the next couple of slides, but really replacing old systems with new ones. You may be in a situation where your fridgie is saying, we've got a good system, but it's running quite well, and that's, rightly so. It's while with the cost of electricity these days having risen from around 8 cents, a few years ago up to 20 plus now, our systems do age, and particularly those that are over 10 years old, they do find obviously increasing wear, increasing operating costs. So it's worthwhile testing that every now and again, just going through those opportunities with, with both suppliers and mechanics to see whether there is, a better replacement that's going to be able to, make a decent payback as well. Because definitely with compressors, motors, and all of those, they do use it well over their life cycle. Their capital costs during their life cycle as well. So just to quickly go over the major parts that you would look at, inefficient chillers, replacing those major, the compressor units is a first protocol. That's where most of the energy is consumed. People will have access to these slides as well at some point. Yep. Just so sorry to be running through these, but you'll find out through the toolkit itself, and also through these, you have an opportunity for feedback and also for asking questions. Secondly, obviously, evaporators, larger evaporators do tend to be a bit more efficient, but there are different features that you can look at as well, and condensing units. There are both, water and air cooled condensers, and you really need to weigh up what you need out of these units. There is sometimes a balancing act between these units. I suppose one important point that we do want to quickly stress is it's worthwhile looking for units that do operate with a high part load efficiency, because like I said earlier on, vintage is the time for wineries, and everything's going to be running chockers flat out, and you're really going to need to look at trying to find systems which you can operate well outside of that period as well. So if you can have something that's running efficiently during the off season, then that's going to make some significant savings. So ammonia is pretty much the bee's knees at the moment when it comes to wineries in terms of refrigeration systems. It tends to cut the mustard in terms of size. Of the smaller scale, these plants can be quite costly. So it is something that needs to be taken with a great deal of thought and consideration before investing. But ammonia chiller plants are relatively cheap compared to some of the other refrigerants that are out there. Particularly when you're thinking about some actually being phased out, towards 2015 under the Montreal Protocol for depletion. So it's becoming increasingly risky to manage, and those losses when you're talking about some of the other ones like R404 and such as well, which are being commonly used, are also incredibly expensive. Over $200–300 a kilo, and when you have a loss of that, it really does add up very, very quickly. There are some other options out there, such as carbon dioxide and propane, but there are risks associated with those as well. E.g., with propane, there's a clear safety risk as well. Those systems aren't necessarily well implemented yet. They may in future, but they are effective. It's just, you do have to take into consideration there is risk of, you're essentially talking about an explosive gas. So, being careful with that. Alternatives, well, and some of these may be a little bit more controversial, and really keen to get anyone's feedback on some of these. But some of the things, particularly with cold stabilization, alternatives include something such as electrodialysis, which will remove the need for the cold stab process as stands, as well as using additives for tartrate control as well. Some of you may be familiar with products out there such as Manostab and CellStab. There is some potential quality issues that need to be taken into consideration with these, given the quality of our wines. Here in SA and around the country, the way to go. It's worthwhile having a conversation with your winemakers. And again, particularly as the cost of electricity has increased in the last substantially in the last few years, you know, there is that conversation to be had. Another good alternative is over chilling at night. So, you know, requiring less chilling during the hours of the day. You know, more time for it to build up some cool during the night, and being able to let that run for longer in the middle of the day before needing to, you know, get the motors running again. It's probably, you know, a very situational one, but installing an underground cool room may be an option in some cases because, you know, temperature does tend to be stable and also at an optimal you know, line storage temperature and humidity at time, you know, during the evening. And so if that's an option, it's a good one, but, you know, sometimes it's very case by case. So just briefly, that's the end of the refrigeration section. I guess as you'll see with the other ones, there is quite a lot of the same type of opportunities available, but, you know, obviously quite a few different ones as well. But at the end of each section, there is a supply checklist available so that you can start to, you know, collect and ask the right kind of questions of suppliers. And while we don't have them as part of this presentation, and will be made available on the portal, it's an energy resource use template that has been put together to help winemakers, wineries collect together the right kind of energy use data to understand, and also to be able to help their suppliers understand, you know, what's realistic in your own situations, because, you know, seen in a lot of cases, the supplier is basing, you know, upgrades against their own experience, which may be more of a and, you know, how these things perform in industry rather than, you know, what's actually specifically tailored to your needs. And, you know, kudos to many that do actually do a great job up front in trying to, you know, try and match a system well. But, you know, there have been a lot of cases that we've been aware of, you know, through the clean tech grant application process, through just general productivity assessments that we've done with businesses, where the supplier has come back with potentially savings that don't look anywhere near necessarily realistic, or don't count all the costs and benefits applicable to your situation. There have even been some cases where we've seen suppliers come back with proposed energy savings that have exceeded the entire use of the site as well, which you know, makes no sense at all. But, you know, they haven't been made aware of the operating conditions, you know, how long things are running, how hard they're running. So the more information that we can provide suppliers to do that, the better. So this tool is essentially aimed at helping to do that. The last one is also aimed, the modelling tool is more something to give you a bit of a hypothetical case to test out some of these opportunities in-house, where, example, you know, where we're making upgrades to compressors or installing variable speed drives and such like that. Just having an opportunity to put a little bit of a hypothetical together to see what, you know, what that might mean. The intent with these isn't to, you know, make you spend hours and hours, you know, plugging away numbers onto a Excel spreadsheet or anything like that. It's really, you know, it's just providing a basic tool, but it's something that we're happy to run through with people during some of the sessions, if you can. Yep. All right. Great. So I'm going to very quickly go through these remaining sections, because there isn't, you know, what you'll see is a lot of the continuing work. But again, with pumping, scheduling the most efficient pumps for a given load, this is really just about making sure you're matching, you know, the pump with what it's used for, getting the right size. I'm not going to dwell on these. Again, with as with the compressors, scheduling multiple pumps in parallel to do jobs can be an efficient way of running. Minimizing the pressure drop of the pipework, it's exactly the same as with the refrigeration suggestion, is in, you know, making sure ductwork is smooth. You're getting as short, fat pipe runs as you possibly can to make the pump, you know, work as minimally as possible. Another quick thing that you can do in there is you also include some turning vanes, as you see in the image there, to help direct the flow around corners within the network as well, because as you can see, if you have a sharp corner, pressure of the liquid hitting that corner is is creating an inefficiency for you quite visually. Okay, so one option where you do have something like an oversized pump or too high, an oversized pump where you don't really necessarily need the flow is you can trim the impeller. This is something you necessarily could do strictly in-house because it does take a professional to do the trimming, but that's one option to help improve the system performance for an oversized unit. Another one, similar thing, applying castings and coatings. It may cost a small premium at at this point, but when doing those, allows can create a reasonable thing in the pump power over time as well. Simple one, installing controls, making sure pumps run when they need to be. This is important as well. Even manually you can do this, but being the mindset right among staff, to the use of the pump at the start. I think transfers is the main call with this. You can save also a lot of water doing this with making sure that you're running your pumping systems optimally. As opposed to variable speed drives, constant speed drives is another way people can go. This is again with oversized pumps where you are running a code. Getting a constant speed drive installed is one way to help make the system run at its optimal condition. So rather than having to replace a whole pump system. A direct pump essentially just means having the pump shaft directly connect the motor shaft connected to the pump impeller, rather than having a second system in there where losses may eventuate. Guys, we've spoken about, so just covering off on those. High-speed motors, again, a familiar one. So wherever there's a pumping condition that is going at a constant speed, need the one might operate at different levels throughout the year. A possible option. And as you can see, we're already at the end of the pumping section. So that, again, you'll find another checklist and tools that can be used. So very quickly going through the on time. So minimum pressure. The lower pressure we can run, the less hard the compressed air system has to work. Working temperature, exactly the same scenario, and same inlet temperature as well. So we're just finding ways to help the compressor system run where it should be. Scheduling multiple compressors in parallel. We've gone over. I'll skim over these that we've seen this already. But I guess one major one for compressors is repairing of leaks. The table that's up on this page here is showing the small up to large leaks. In one less than a millimetre, at this or about 5 years worth of savings that can be made. Back when the cost was 8 cents, so around the 20-cent market now. These very quickly add up, and it's very hard to find some of those smaller leaks. It is worthwhile investing in getting either someone out and do an ultrasonic leak detection test, or purchasing. If you are larger and you're going to be doing these fairly often, purchasing a unit yourself to be able to go around and find some of these leaks and fix them up. Pressure drop through the pipe and hose network. Thing is, we've discussed relocating compressor units where they're in an exposed position. Internal cooling with external cooling, we've discussed, and controls we've also discussed, as with variable speed drives. Automated compressor staging. So one last one here is just making sure you're using air compressor systems for appropriate uses as well. People tend to use their compressors for potentially just cleaning open spaces where it's easily applicable to go and use just one of these handheld units instead of drawing on the full resources of one big compressor to do so. And that's it. There. Okay, so hot water and steam. Similar to with compressed air, minimizing the pressure, and with refrigeration, minimizing the pressure, so the temperature. So you heat, the better. Reducing the blowdown. So having blowdown, loses a lot of waste hot water. Will waste a lot of hot water that could potentially either continue to be used, or it also loses the water. So what we're looking to do here is try and keep as much of that within the system as possible. So getting an automatic probe or similar to be able to control how blowdown is occurring will help to manage that load. Monitor temperatures. So by controlling the flue temperature, you're able to improve the the operation of the boiler itself and the control of the fuel ratio, so that again the boiler is running in a good condition. Still, with insulation and kettles and things like that, maintaining your water treatment to reduce scaling. I think you can see through the table here that the scale build up on your network increases the, I guess the heat transfer efficiency, and also leads to excess fuel being burnt. Maintaining steam traps. They will release steam that continue to be used, as well as having steam switch constantly exposed, becoming waterlogged, and reducing how much efficiency there is in the heat transfer as well. I'm very quickly trying to speak through that. So repairing leaks in the pipe network, doesn't really need too much more said about that. There are options here. What we're really trying to do is recover heat from potential waste sources, such as your flue gas or in your blowdown, and put that back into the system to heat hot water and suction. Air preheaters. Obviously, the combustion gases work more efficiently when they're warmer. So, by installing an air preheater, you can improve the efficiency of that combustion process. Insulation on pipe networks. This is similar to refrigeration, but I guess particularly with something like steam and where you have bends in pipe network, insulation can tend to wear more. So it's worthwhile in a lot of cases where you do have potentially even getting someone out with a thermographic camera to take a shot. As you can probably in this image here, that insulation is worn. That insulation fixed up to maintain the integrity of the system and help prevent unnecessary heat loss. We skim over these, but the main thing at the end will be so that just helps to manage heat loads. An accumulator is essentially a large tank filled with water, and it's heated by that's true, and obviously when it's temperature, things go through and has no need to continue here. But when there is a pound in, then the pressure drop system, which takes to help overcome those loads. So it's very the last HVAC, not so much used in the winemaking, but more so for this is relating to operator comfort, as well as important what would be in barrel store. So this first point about adjusting temperature set points, more directed towards operator comfort. It's more productive in a comfortable environment, and it's lighting. We're at the tail end of the opportunities here, so these are the small savings, but again, we maintain $50 is $50. So this one here, maintaining the temperature as high as possible will help to, at least in summer, and a bit lower to reduce the load on your HVAC equipment. In fact, we have a different situation, obviously, where you need to have a temperature between that 15 to 18 degrees, and as you head down, to use something like an evaporative cooler, you might need to move towards your refrigerated coolers as well. But again, it's a conversation to have with your winemakers about what's suitable to you. Cool. Similar to an earlier point, being able to use the outside air to cool when, typically cool when it's cooler out there than necessarily inside. So rather than having active cooling, you can use the outside air. Most HVAC units are able to be fitted or already have economy installed. Making sure the building is well secure, as well as all your, and you're not allowing that waste heat to be lost through. A main point of call here would clearly the roller doors, which may be left open consistently. Getting one mail door fitted, having just going around with pop stuff, buying your your sillies open, just to make sure you're where possible. Where and relocating. The last point here is to really push that this is more important as well in this when it's in your space, and see if your roof is getting air as well. So just having that insulated so that it's getting from the HVAC unit chiller through to the point of exhaust without not waste. Control we've already covered. This point, a pretty clear one, more of a staff management one as well. We can hear about process growth, getting sensors, having timers on, manage lighting is turned on and off is quite good, and also good practice as well. We see these outside with loading bays, maybe with a padded light sensor to prevent light throughout the day. Minimum lighting levels. Sometimes areas are well overlit. It's possible to de-lamp them, or either use more directional lighting in high, in intensive work areas, rather than having a broadly lit area of lighting where you're wasting a lot of that light. Keep going with that. A little option again. It's similar to with HVAC. We're talking about people's comfort levels and being able to use passive systems as well. So increasing the use of daylighting lighting. So you can sometimes you can do this with building fittings. Other times, you can get small daylighting devices installed into windows and openings to help increase the amount of natural light that's reflected through the building. Similarly, and I'm not asking you to go ahead and necessarily paint all your walls white here, but any opportunity worth considering to help increase the amount of light reflected through the inside of your facilities, your buildings, using curved roofs, using light-coloured paints will help increase the amount of perceived natural light through the building. Finally, the last one about installing more efficient lamps is a relatively straightforward one. We're not talking about small savings here, but in some wineries, small savings still, when these lights are on consistently through the year, they do add up, and they add up to several thousands of dollars potentially as well, particularly on larger sites. The last point around installing LEDs or luminous exit signs, come on, we're talking, literally a few dollars, but they're lights which are on, and they have to be by law on all the time. So don't cost a great deal to swap over, but definitely a worthwhile thing to do, even at the simple end of the scale. So that really covers off the main. The business case is something. Do we want to go through that in much detail? Yep, very, very quickly. We'll just go through the business case. But really, what we're talking about now, this is structured like the earlier sections. This is just more so about where there are opportunities, providing a bit of general guidance around developing the business case, here is most businesses, the numbers where it starts and where it stops. What I guess we're trying to stress is, where there are multiple opportunities that can be taken advantage of and they're going to provide savings, then thinking about, without sounding too much like a management consultant, thinking about the strategic benefits of those upgrades is, what's the opportunity that provides for the business, to help improve your productivity, improve your market, your market presence as well, rather than just thinking purely about the payback as well. So, energy efficiency savings are not necessarily just enough on their own, and there are other factors that need to be taken into account, particularly when you're taking a long-term view, when you're thinking about, the risks that might come to your business. And for small businesses, cash flow is king. Cash flow is king for all businesses, but you live by cash flow. It really needs to come back to what it's going to make the biggest impact for your business now and in that longer view as well. So, couple brief points. Adding up all the business benefits that you could possibly throw in there. Energy efficiency isn't necessarily the only thing. One of the biggest things is other savings in areas such as water and waste generation as well, where you can make multiple savings like that can be great. Improve safety, reduce labour costs. Maintenance costs is a big one, particularly with something, as a simple example, something like with your lighting. Replacing your old metal halides with LED lightings in your warehouses might be a moderate payback in terms of the lighting itself. But when you take into account the additional costs of that maintenance and with the metal halides, you may be up there every 6 months, a year on a cherry picker, or hiring someone in to go and do that, as opposed to having something that might have a longer lifetime of around 10 years, then those do add up very quickly. Same with if you've ordered a new piece of equipment in from overseas, you may find that if there isn't that local knowledge to maintain equipment, you might end up having to fly someone in to take care of it. So these are sort of considerations that are a bit hidden and can definitely impact the viability of a project as well. For those that are looking at leveraging some of these for their branding and company profile, that's definitely one of the benefits that can factor in. Generally not the top of the tier, but something that's worth factoring in as well. All the costs, there are a lot of costs, and we don't need to sort of dwell on these and on the following slide either, but those maintenance costs and those downtime costs are something that's important, as well as the opportunity cost. There are, in the broad range of things that can be done, and is this the best thing to be spending your money on at the moment, or is there something else that can be done? So yeah, just assessing the real costs and benefits. Assessing all the risks, not much to go through here. Very, very briefly, just touch on organisational risk. Obviously, that's one which is a bit of a hidden one. Sometimes, some of these upgrades do require, staff training or, a different way of practicing within the business. So if you can get staff to, that shift does require work and something that can be overlooked that can really extend the payback potentially as well. Yep, and so very much, I guess, by the way you look at these processes is through what you might consider a bit of a J curve. It includes 3 parts: your investment cycle and your payback cycle, which has phase of investment, catch up, blue sky. What we're trying to do, I guess, is get to the blue sky as quickly as possible, but most people may focus purely on the payback. What we will try and get people to really consider in this is the level of risk that's involved in that cycle as well. So, what happens if something goes wrong? It's not something that people necessarily want to think about, but it really is important to be able to think what happens if I've measured what happens if it does take longer or costs more for me to do. So a few quick rules: measure and depth of the valley, not just the width there. And emotionally connected to the J curve. People might, start a project and get really excited about it, what you don't want to happen is, to keep sinking money into that project and going, oh, it's nearly there, and it costs you an extra 5, 10, 15, 20, 30,000. There's got to be a point where you decide that's it. If we get to this point and we're not seeing a turnaround in the that payback side, that implementation side of the project, then time to pull the plug. It's a hard thing to do. Two curves at once. So it's like trying to juggle balls or spin plates. If you try and do too many of these at once, you're likely to drop all of them. So best to just manage those and make sure you're not setting yourself up for a big hit by not being able to take all of them on board at once. You're having a plan to move as quickly, from phase 1 to 3 as possible. Again, it is important with these projects to have the right kind of mindset. At the start of the project, it's all about the innovation. It's all about the concept, getting the idea right, getting it moving, and in the second half, the take mindset implementation phase of let's start seeing the payback here. Let's start seeing the delivery. Let's not focus on continuous change to it either. Finally, it's touching a dev curve for just a really important point. If you've come up with a lot of ideas, they may not be viable now, but by having that on the books, you're able to keep them in mind for the future. We've been cases with a number of wineries that have thought, yep, with good refrigeration upgrade, but the cost of power right now isn't that great for us. But 3-4 years on, the cost of power has doubled or even tripled over the last few years as well. So that opportunity that was there is now a viable opportunity and something that they want to proceed with. So I'm going to leave it there. I'll hand over back to Mark to take care of this
last one. But I guess the next step for us is taking care of one-on-ones and working through these toolkit updates, and really looking forward to getting some of your feedback on the process and on the tools and what kind of updates we can make. Sorry to take a couple minutes extra. I did have to try and fly through this, and honestly, this is a 2-hour presentation condensed down to just a little bit over 1. So thank you very much for your time, and I'll hand back over to Mark.
Okay, thank you all. Just a reminder I put up on the screen now, a reminder, your feedback survey, which should trigger as soon as we leave the session. You can access the toolkit by going to the WineSA website, look through the, it doesn't have to necessarily be members, that link's a bit there, but information for the general public. Go to the environment section, you'll see an energy efficiency page, and then you can link through to the toolkit and the materials will be there. As we've had a bit of chat along the way, there's a number of additional materials that we will be loading up there. For example, the slides from today, and so on. There are the key opportunities and the list of supplier questions that you can download and then use those yourselves. Most importantly, get in contact with us if you need anything further. And I'll just go back to, I'll just flip the screen back over to Steve's at the moment, although I'll stay on the line. And what we will have now, I think it's gone into, there it is, the information is there now. So contact myself at Sawyer, Aubrey Thomas at Zero Waste, and at 2XE, Nick Pelosis and Steve Sindler over the next period of time whilst this project is operating. They're the guys that are going to be delivering on the ground. Zero Waste, we've got a range of programs. You saw the message come up earlier and what can be delivered. And of course, Sawyer will be hosting the information on the material. All right, that's all we have today. I can't see any other questions that have come up or any other information in chat, so I'll call it a close at that, and we'll end. Hang on, I'll just come back to my screen so that I can close it off and end the session for now. So thank you all very much for attending.